Okay, so we are going to start looking at chapter 27 now. So we've just finished chapter 20 on applied measure 1. And in that chapter, we had taken down that area is the amount of flat space a shape occupies, and perimeter is the sum of the length of all sides of a shape. So we looked at the area of a rectangle, and we saw that the area of a rectangle was length of the base times the height. So if I had a base here on a rectangle, I was multiplying it by the height. Now, what we see is if I have a triangle, it's really half this area of this rectangle. Okay, so my area of a triangle is half the base times the perpendicular height. Okay, so half the base by the height is going to be my area of a triangle. So can you open up in your books, please, page 448, and I'm going to ask you guys to have a look at question 1, 3, 5 and 7 there. Okay, so we're doing all the odd numbered questions from page 448 and 449. Okay, so I'll go through question 1 with you guys. Just question 1A. Okay, so page 448, question 1, we'll go through, well, let's do question C together. Okay, so let's do question C together here. Okay, so you can pause this video now if you want and try C yourself first before we go through it. Or you can work ahead of me. Okay, so question C has a triangle that looks like this. Okay, and it has 13.9 centimeters here, 92 millimeters here, and then it gives us this side as well is 6.3 centimeters. And then it shows us the perpendicular height. So maybe I can try and write this a little bit smaller. So 6.3 centimeters. The reason why I'm writing that small is because we don't really need it for the area, but we will need it for the perimeter. For the area, remember, we always use the perpendicular height. So this height here that they give us, which was 5 centimeters. Okay, so the first thing we always have to remember, guys, is we want all of our units to be the same before we start trying to calculate things. So this 92 millimeters here, that stands out as, I suppose, not really working for us because it's not in the same units. All the rest are in centimeters. So what is 92 millimeters in centimeters? Well, it's 9.2. So 9.2 centimeters is what we're going to be using there. Okay, so first thing it asks for is the perimeter. So how do we find the perimeter? Well, we just add up the lengths of all sides. So here it's going to be my 13.9 centimeters plus my 9.2 centimeters, so 9.2 centimeters, and the 6.3 centimeters here. Okay, so all three of the sides there. So plus 6.3 centimeters. Okay, so type them into your calculator. So we have 13.9 plus 9.2 plus 6.3, and we get 29.4 centimeters is the perimeter here. Okay, now for area. So our area here, and remember our formula for area is half the base multiplied by the perpendicular height. Okay, so I'm going to fill in. So I have half. Then remember, when these are right beside each other, it means they're multiplying. So I'm going to show that just by using brackets here. So my brackets, and then what's my number, what's my value for the base? Well, the base is 9.2 centimeters wide. So 9.2 centimeters. And my perpendicular height then is 5 centimeters. Okay, that's the perpendicular one. So remember, when it's a perpendicular height, it's at 90 degrees to the ground. So that's this height here, so 5 centimeters. Okay, so we can type that into our calculators. So half times 9.2 times 5, and we get that the area is 23 centimeters squared. Okay. Okay, so I asked you to do question 1, question 3, question 5, question 7. So can you try them yourselves now? And okay, and yeah, that's it. Okay, we'll go through them in Wednesday's class, and then we're going to move on to looking at circles and discs. Okay, so first of all, the area, okay, so we have that is the amount of flat space a shape takes up. The perimeter is the length of all the sides. So looking at these two triangles here, we can apply our formula that the area of a triangle is half the base by perpendicular height. Okay, so these here are two examples of our different triangles, and we have found the areas. Okay, now you don't need to learn that formula off. It is in our formula and log tables. Okay, so it is in our log tables here. So this is on page 9. We have area is half, and now here it's H is still our perpendicular height, but they have A here, and they've shown in the diagram here that A is the base. Okay, so that is in our log tables on page 9, but it's also something that maybe you might recognise having heard in primary school. Okay, so looking then at a disc. So when we talk about a disc, what we're talking about is the inside of a circle. It's like the area within the curve, whereas the actual curve is the circle. But in saying that, like, to be honest, you get away with calling a disc a circle. So we can just use the word circle if we want. So if we're asked for the perimeter of a circle, again, that's the length of the outside of the circle, and that's called the circumference. Okay, we are going to look at our equations for circumference, and we can practice using those a little bit. Okay, radius then, that's the line segment from the centre of a circle to any point on the circle, so we can see that here. So when we talk about a point on the circle, that's on the outside. Okay, so the circle, remember we said it's the actual curve. It's not just anywhere inside here. So when we say to any point on the circle, it means to the outside line of the circle. Then our definition of a diameter uses the word chord. So a chord is just any line segment with endpoints on the circle or on the circumference. So the diameter is a chord that passes through the centre of the circle. So here's a diameter here. Okay, now we have infinity many diameters that we could draw in and radiuses that we could draw in. Okay, so there is just a couple examples. If you're given the diameter and you're asked to find the radius, the diameter is twice the radius in length. So if you're given the diameter and you're asked to find the radius, you just half it. If you're given the radius and you're asked to find the diameter, you just double it. Okay? So we are going to just look at a couple of formulas before we go on to page 452 to try some questions. So here, our area of a circle, we can use the formula pi r squared. Okay, so into our calculators, we can type pi by pressing shift and then see the times 10 to the power of x. It's beside the answer button. So if you go to your equals button on your calculator, it's 2 over to the left. Okay, so in my calculator, I'll show you where it is. So we're pressing the shift button up the top left. So shift, and then we are going to press the button, it has a little pi up here. Okay, it's there as times 10 to the power of x. Okay, it's 2 buttons over from where we have, so we had answer beside it, and beside that we have the equals button. Okay, so that's how I type pi into my calculator. I press shift and then I press this button here. So to find the area of a circle, so to find my area of a circle, we can write these up here. So I want these written into your copy, just like we usually would in our notes. Okay, you've taken down, let me just go back to it, the slide on the area of a triangle, what we're talking about. Okay, if you want to take down a note on that, you can too. Okay, so you can pause that and get that stuff down, what's highlighted in white. Okay, then that's just there to help you. I'm also going to get you to take down this slide here, and then just these formulas here from this slide. Okay, this writing up here you already have down from the last slide. It's just, instead of being bullet pointed, I have just made it all one paragraph. Okay, so we have a equation for an area of a circle. The reason why I'm not getting too caught up on what all this means is we can really see how easy it is to use these equations when we go and start trying these questions here. So I'm going to get you to take down these equations, but they are also in your log tables. Okay, so I think they're on page 8 of your log tables. Let's have a look. Yeah, okay, there they are there. So they're on page 8 of your log tables. Okay, the area there is pi r squared, and then the length, so they give the circumference there as L, is 2 pi r. Okay, so as long as you know where to go to find them in your log tables, you don't need to turn them off. Okay, so let's say a question gives us a circle that has a radius of 4 centimeters. Okay, so it gives us a radius of 4 centimeters. And it says, okay, so take pi to be 3.14. Okay, so if it doesn't say that, it's fine. We can actually just type pi into our calculator, but we'll get to that in a little while. Okay, so what I'm going to do is I'm going to find the area and the circumference of the circle. So we said my area of a circle is given by pi r squared. Okay, so what I'm going to do here is I'm going to write down the information I know. So I know that we said pi is 3.14. So I'm going to fill in for pi as if this is algebra and it said a there and it said a is equal to 3.14. And I know my radius, it's given to me in the picture, it's 4 centimeters. Okay, so I'm literally going to fill in this formula here. I'm going to fill in, instead of pi, I'm going to fill in 3.14. Instead of r, I'm going to fill in the 4 centimeters, or just 4. And then I haven't used this squared yet, so I'm going to carry it down. So it's almost just like, it's actually exactly like subbing in algebra. Okay, so once I do this then, so I can look at that and say, okay, well, if I'm using BIMDAS, what do I do first? So let's think back to our order of operations. Okay, now at this stage, you can just type that into your calculator, but let's just think about it with BIMDAS. Okay, we can't simplify our brackets. We do have an indices, okay? Here, this squared, that's a power or an indice, so I'm going to do that out first. So I'm going to have 3.14, and I'm going to multiply it by 16. 4 squared is 4 times 4, which is 16. Okay? So when I go to find my answer, I'll just multiply 3.14 times 16, and I get 50.24. Okay, now I found an area, so what's my unit going to be? If my length here was centimetres and its area, my unit is going to be centimetres squared. Okay? And then let's have a look at, okay, if I wanted to find the circumference of this. So if I wanted to find the circumference, okay, so my area for the circumference is 2, or my formula for the circumference is 2 pi r. So again here, I am going to fill anything in for 2. I can fill in r as 3, or pi as 3.14. So 3.14, and then or I can fill in my 4 centimetres. So 4 centimetres. Okay, so this is all just multiplication. So I can just do it all out. So 2 times 3.14 times 4, and we will get that the circumference has a length of 25.12 centimetres. Okay, the circumference is a length, so it's just centimetres is the unit there. Okay, so that is question 1 from page 452. That is question 1 done for you there. Okay, now what I want you to do is try questions 2 and 4. Okay, we are then going to look at, so you're going to do questions 2 and 4. We're then going to look at together questions 6, 9, and 11. Okay, so you can pause now and give them a go. I will give you some hints on how to do those ones in the next video.